Howdy everyone, Howdy everyone, Dr. Nir Regev here, and thank you for joining me for another episode of Paper Talk. This time it's a paper that is titled Chebyshev Moments Based Drone Classification, Recognition, and Fingerprinting. And this came from a few universities in the UK, Italy, and the Netherlands. And Francesco Fiornelli, professor, there is one of the people I follow. And by the way, I'm walking on my treadmill, getting my steps in, so don't mind my movements. Okay, so what this paper posits? They posit that if you extract Chebyshev moments, doesn't really matter exactly what mathematical operation is it right now. You get superior performance in the task of recognition, classification, and fingerprinting of drones, and it's all based on the micro-Doppler signatures of the targets. The way it works, there is a nice introductions here. By the way, one of my papers is cited here. That's accidentally I saw that they said recently the latest deep learning frameworks have been also investigated for this challenge as in number 3. And here you see this is the paper titled Classification of Single and Multi-Propelled Miniature Drones Using Multi-Layer Perceptron Artificial Neural Network. It's one of my papers together with Ilya Yofe and Dov Volich, my professor then, in 2017. And we demonstrated how multi-layer perceptron can provide high classification rates of drones with different propellers. Now they go on and they survey some literature, and then they propose a method capable of automatically classifying radar signals related to drones, exploiting their intrinsic micro-Doppler signature. In particular, following the line reasoning as described in A, the method extracts the Chebyshev moments, which is described in 12 in this paper, taken from image analysis actually, from cadence velocity diagram obtained from the short time Fourier transform, STFT, of each recorded signal. The choice of using these image moments is motivated within the radar context for the useful characteristics. In fact, these moments, differently from the Zernike moments, are directly defined on a discrete set, therefore no approximations are needed in their implementation. Additionally, they are characterized by symmetry, which can properly be exploited to reduce both the computational time as well as the required storage in the database. And they provide an analysis of complexity. But the pipeline is as follows. There is a signal coming in, we do the short time Fourier transform, and then we do CVD by doing an FFT across the time axis. So it's basically double FFTs. And then we extract from this image, we extract Chebyshev moments, and you will see that the order of the moments is also some sort of a parameter, hyperparameter in this work. And then these moments will be a feature vector. They normalize it by its standard deviation to avoid biases, and then they test this method with a few different algorithms, machine learning algorithms, like SVD, like SVD with Gaussian kernel, or random forests, as we will see later. And they are testing it on 2 databases. One is the KU band dataset composition that I cite here, and the other one is their own dataset. They also cite that, and they propose a k nearest neighbor support vector machine with Gaussian kernel, like I said, and random forest classifier, and they compare between, for example, a drone and a bird, and you can see that they compare between accuracy and average F1. F1 is more appropriate to this data set because of the imbalance in the sets. So you can see here that the Chebyshev with random forest is gaining the most F1 score, average F1 score, and they compare it to the SVM random forest as well as the other method, the Crow-Chook based approach. Okay, Now, exactly how do we extract the Chebyshev moments and the Krochuk? What is the Krochuk-based approach? They don't get into in this paper. And in the course AI in radar signal processing that I developed and proposed in my community academy and website, we talk about extracting features, and we talk about doing actually SVM, random forest, and other classifiers with higher order moments. So it's very close to what we learn in this course. And this paper is actually a part of the case studies in Module 5 for this course, or Module 6, I think it is. And this will be posted as is for Module 6, because there we discuss case studies and other works on the micro-Doppler and radar-based classification of targets. Okay, so here they compare between, they try to classify between fixed wing and multi-rotor, and as you can see that again, in terms of average F1 score, the Chebyshev with in this case random forest is gaining the most F1, average F1, and you can see that it's actually very steady in terms of the moments order, so you don't have to go into high order to get nice results. And then they compare between loaded, unloaded with 6 payload classes in the right side, and again their method is gaining the best accuracy for both. And here you can see that there is some dependence on the moments order. So for example, I think that above 10 will be the best here in these graphs. Okay, so both KU band and S bands, and you see that the payloads that they considered are 0 to 600 in 0, 200, 300, 400, 500, and 600 grams of additional payload on the drone. And they still have very nice results. You see here that it reaches a 0.95 accuracy, and here just between loaded and unloaded it's almost 1 in terms of accuracy. All right, so then they conclude the paper, they do the acknowledgement, and that's it. So that's it for this episode of Paper Talk. This will also be in the course, in which we will actually dive more into how does this method works exactly. And that's it. Thank you for listening. Thank you for joining. And if you like this, just click subscribe, click like, comment if you want me to cover other type of papers. And until then, see you in the tall grass. Regev out.